queremos aportar como de norte a sur. Así que voy a hacer una breve presentación de nuestra próxima panelista principal, Cathy O'Neill. La voy a hacer un pedacito en español y luego pasaremos directamente al inglés. Cathy es doctora en matemáticas de la Universidad Harvard, inició su carrera como profesora de la Barnard College, trabajó como quant en el fondo de cobertura Dijon y más adelante luego en el mundo tecnológico de Nueva York pudo formarse o ser colaboradora también como en ciencia de datos, científica de datos. Es autora del libro conocido como Weapons of Mass Destruction y actualmente es la CEO de ORCAA, que es la firma especializada de ella en auditoría algorítmica. So, welcome to Cathy O'Neill. She is here for us today. So, as I was introducing before, she's a doctor in math from the University from Harvard. And she has been starting her career as a professor in the Barnard College. She has been also working in this show. And later she has been working also as a data scientist and is the author of Weapon of Mass Destructions and actually is the CEO of her own company, which is O'Neill Risk Consulting Algorithm Auditing. So a big clap for her, please, and welcome again.
Thank you so much. It's an honor to be here. Thank you for inviting me. Today I'm going to talk to you about what I do for work, but it starts with a little bit of an introduction on the book I wrote, Weapons of Math Destruction, which I just signed. Camila has a copy, but it's also in Spanish. 1 minute. Okay. I'll just ad lib. By the way, we've been here for 3 days. It's a beautiful city. We went up to the Montserrat. It was very gorgeous. So I want to mention that you guys are studying data science. I think of data science as a quantification of expert knowledge. So it's pretty rare that you learn something completely new about the world. What you do is you talk to people who know something already, the experts in a certain field, and maybe they tell you they know 2 things. They know an effect or a different effect. So for example, when I started doing data science, I was working in travel. Do you guys go to the internet like Expedia or something? You probably have a different thing here, but to book a flight on the airplane. And I was working with people who are experts in travel. And they told me people who want to go on vacation, they book their flights on Saturdays. People who have to go to business trips, they book their airplanes on Tuesdays. That's like just a rule of thumb for experts. They also knew that people wanted to plan their vacations about 4 weeks before the vacation. So it'd be 4 weeks before like a special holiday that you'd start seeing sales for that. But what they didn't know is how much of an effect that was compared to the weekly cycle that they just described. So my job is to tell the experts how these things compare to each other mathematically, how to measure them. But that's most of data science. You're not inventing new things. You're measuring things that people know already. And sometimes you're predicting things in a mathematical way that people know is going to happen, but they don't know exactly how much it's going to happen. So you're making it more precise. So that's kind of how I think of data science. Sometimes that precision is really important. So I'm going to start with my book, Weapons of Math Destruction. And what I realized and why I wrote this book is because I realized there were a lot of algorithms. Back then it was called big data algorithms, but they were predictions using mostly machine learning. That were actually pretty harmful for people. They were hurting people. And they had 3 characteristics. One of them was that, well, the ones that I focused on in the book had 3 characteristics, that they were important, that they were making important decisions about people's lives. So do you get a job? Do you get a credit card? Or what's the interest rate you pay on your credit card? That kind of important thing that matters to people. Sometimes it was even more important. Do you go to prison? How long do you go to prison? Do you get fired from your job? And I'm going to give you examples. So they were important things, but nobody understood how it worked. They were mysterious. They were secret, actually. And when you add that together, when you're like having important decisions made about you in a secret way, and by the way, they're so secret that you don't even know they're happening sometimes. But even if you know they're happening, there's often no way for you to complain, to appeal the decision. Like if you don't get a credit card, you don't get a credit card. If you don't get a job, you don't get a job. You can't complain about that. And you probably don't even know why. So this is the third characteristic, was that they were unfair. They were destructive, especially to certain types of people. So I wanted to look into that. And I've sort of devoted my life since I started thinking about this to trying to figure out how to help people who are being harmed by algorithms. But before I go on, I want to tell you what I mean when I say algorithm, okay? So this is my son, and he loves Nutella, always has. He's older now, but he still eats Nutella all the time. And the reason I'm showing you a picture of him is because I want to tell you what an algorithm is. It's not that complicated. It actually is not technical. It's something you do every day. I do every day. Whenever you decide what to get dressed, how to get dressed, like what clothes to wear, you're predicting something and you're optimizing to that prediction. So you're saying, I want to be comfortable today. And you go look at the clothes you have, like what's the most comfortable thing today? Because you know what the weather is, you know what's clean, you know what you're going to do that day, okay? But you could be, instead, you could say, I want to look professional. And you'd look at the same clothes, the same weather, but you'd have a different goal in mind, right? So you'd wear something else, probably, unless you have really comfortable professional clothes. Well, the same idea here. For me, this question is, what do I want to cook for dinner, right? What do I want to cook for dinner? And I want to cook a successful meal. I know what ingredients I have, how much time I have to cook. But for me, I want to cook something, and I'm in charge of dinner because I'm the mother. I want to cook something that will be successful to me. And that means that my kids will eat enough food and they'll eat their vegetables, right? That's not what my son would want, right? He would want as much Nutella as possible. So it's important to realize these are both predictions. These are prediction models. And really all I'm doing is I'm thinking about all the historical data, which in this case is my memory, and your memories about your clothing, like this was comfortable last time I used it, right? So memories are data, historical data, and the goal that you have. What is success? What is success in this moment? And then you optimize your algorithm to try to make it most successful, the most successful possible dinner that will get my kids to eat vegetables. Not the same dinner as he would have, right? So two things. First of all, it really matters what your definition of success is. If my son versus me, totally different meal. That's the first thing. So we're going to come back to that definition of success. The second thing, though, which is just as important, is the person who has power decides. And in my case, of course, I'm the mom, so it's appropriate for me to have power. But most of the algorithms that we talk about, that we interact with, that are formal, that are using computers and lots of machine learning algorithms, it is not us that decides, right? We're not the ones in power. It's the companies that are using it on us that's deciding what the definition of success is. So here's an example of something that I considered very unfair when I was studying. Actually, I spoke to her. I learned about this from my best friend, who's a high school principal, and she told me her teachers were being fired based on an algorithm that nobody understood. And I found this woman, Sarah, who had been fired. She couldn't explain the score. Nobody could explain the score. But she, along with hundreds of other people, were getting fired all over the country based on this scoring system that nobody could explain, called the teacher value added model. By the way, I should mention that it was it was introduced in the United States because of something we were worried about called the achievement gap, which was the fact that richer children did better on tests than poorer children. That gap, the difference between those scores was growing. And the idea was, let's get rid of bad teachers. And if we get rid of the bad teachers, then this achievement gap will get smaller. By the way, there was no evidence that this is the fault of the teachers. In fact, if you look historically at achievement gaps in other countries and across time, you see that it really changes with inequality itself. But in this case, we had both Democratic and Republican presidents who wanted to say that they fixed the achievement gap, and they created this scoring system that would fire teachers who were bad. It was called accountability for teachers. But it was a system that was not itself accountable because it didn't work very well at all. And it was firing people like Sarah. I'll just say one more thing about that. It really only fired teachers in poor areas of the country, usually urban areas with lots of Black and Hispanic kids. It didn't really have power in the richer places with richer, whiter kids. And of course, as you can imagine, getting your teacher fired, especially a good teacher like Sarah, because Sarah was a good teacher, is not actually helpful for those kids. So instead of decreasing this gap, it made things worse for poor kids and increased the gap. So it did the opposite of what it was supposed to do. And that's typical for these weapons of math destruction that I am talking about. They are supposed to do something to solve a hard problem, but instead they make the problem worse. This is another example of an algorithm that was used in healthcare. This happened after my book came out. It was called the Optum algorithm. And the idea was that they wanted to help patients that have many, many problems receive care. It's a good idea in some sense. Like when somebody has like diabetes and they have a heart condition and they break their leg, you might not give them the same medication as somebody who had only a broken leg, because there's like complicated things that happen with medications. And sometimes if you get the wrong treatment, you end up sicker and it's more expensive. So the idea was Optum wanted to help those people. But they used historical data to decide who to help, right? Because remember, we just talked about how do you build an algorithm? You need historical data and a definition of success, and that's it, right? It's all you need. So the historical data they had, because they were a health insurance company, was how much did people cost? And they just said, we want to help people who look like people that cost a lot. So like people who cost a lot, we're going to give them help, extra help. People who didn't cost a lot in the past, we're not going to help them. So instead of actually looking for the true people in need, right? People in need are the people with complicated medical problems. They didn't look at complicated medical problems. That was hard for them. So instead, they just looked for people who cost a lot or who might cost a lot in the future. The problem, of course, is that some people in the past didn't cost that much, even though they were very sick, right? So there's a historical bias against treating poor people and Black people and Hispanic people in the States. And so those people were overlooked. They were ignored, even though they needed the help. So that's an example of an algorithm that was offering help to people who didn't need it and ignoring people that did need it. Are there any questions about that? Do you understand what happened there? So just to repeat, they were using historical data, but the data, and they were asking who's going to cost the most, instead of the real question, which is who has a medical problem that's complicated. So that switch where you don't ask the right question, you ask a slightly easier question, because it's easier for them to answer that cost question. That's called a proxy. You're like, well, we don't have at our fingertips, we don't have the thing we really want to study, so we're going to study something that's close. It's a proxy. It's called a proxy. It is kind of close, right? I told you that people that have complicated medical problems are often expensive, but not always. So that it breaks down. It's not a very good proxy, especially for people who historically, people like them, were historically not treated well. So it has that difference between the thing you really want to be measuring and the thing you are measuring, that failure of proxy. That's what I focus on in my work. There's another example of a kind of historical data bias that I want to give you an example of. This is facial recognition software. Do you guys have this all over the place in Colombia as well as we have? Well, there was a lot of companies that were building this facial recognition software. Amazon was one of them, but there were a bunch of them. IBM was one of them. And they basically had pictures of people who worked with them, people who worked for them, essentially, at these companies. They used those pictures to train their algorithm. And they said, oh my gosh, our algorithm works 99% of the time perfectly. But they had so few darker faces and so few women, because most of the people working for them were white men, that it actually, if you broke it down by category, it worked extremely well for white men and not well at all for other people. In particular for darker skinned females. And this is true. I mean, they ignored this when they were looking at their algorithm, the success of their algorithm. They weren't looking at these by category. They were only looking at the whole group. And since white men were so overrepresented in the data, it looked really good. Does that make sense to everyone? And I've talked to people at other tech companies like Google, and they have these big piles of data of pictures of people. And I ask them, how overrepresented are white men in this pile of data? And they're like, we don't know. We don't even look at that. They just don't ask that question. Now, I want to bring up these questions that hopefully you're starting to think about. In the previous example with this, I didn't tell you who is harmed by this. I'm telling you that it doesn't work as well for Black women, right? For darker skinned women. But that doesn't necessarily mean it's harm, right? That's not harm yet. That's just, it depends on how it's used. It might be harmful if it's used against people, but it's not harm yet. Whereas this previous example is harm. This previous example is harm. There are people getting hurt in these things. Not yet here, right? So one of the things I focus on when I think about algorithmic harm is like, well, how is it being used? Exactly. Because I want to know who's being hurt and how and when. And so I call that context. And what is the exact context? In the facial recognition example, there are contexts where you can imagine there's harm because of those failures I just mentioned. But there's other contexts where it's not harmful. It doesn't really matter. It might just be annoying, but not really harmful. Like if you're trying to get into your place of work, and the recognition software fails to recognize you, but you can wave at a security guard and they'll let you in. That's not really a harm, right? It's not that bad. So the context really matters, because if instead it's the police and they think that they recognize you and they arrest you and put you in prison or put you in jail for 2 weeks, which has happened with bad facial recognition, that's harm, right? So we want to make sure that we are thinking about the context really specifically to know what harm is. And also, what does it mean to be fair? When I mentioned the story with a health insurance company, they didn't ask that question, even though everyone in the world of health insurance and in the medical field knows about the historical bias against poor people, against people of color for medical care. They didn't think to ask, how do we make sure this algorithm is fair? But even if they had asked that question, what is the definition of fair? That's actually really tricky. So that's actually what I do for work. And by the end of this talk, hopefully you'll understand a little bit of how I think about it. And then when I say how to set thresholds, that's the third question. Like, how fair do you have to make it? Because fairness is relative, right? It's subjective and is relative. And so you could say, well, it has to be fair within 5%, or this has to be fair within 10%. We'll see what that means. But that's a separate question of what do you mean by fair, and how fair do you need things to be to make it legal or whatever that is. So the kind person who introduced me told you that I work at my own company, that I audit algorithms. I have 3 types of jobs there. First of all, when people are in a lawsuit, they're suing because there's something that they think is basically unfair, right? So if people get together and say, it doesn't have to be of fairness on the grounds of racial or gender issues or anything. Often the times I'm being hired to work in lawsuits where people think that the loans that they're getting are unfair, that it's like predatory loans, like they're called payday loans in the States. I don't know how I'm sure they're here too, but they're like loan sharks, right? They're giving you unfair terms, and then they're rolling you over into new loans, and you could just never pay enough to get out of them, right? So sometimes that's what I'm doing. And in this case, those are called adversarial audits because I can ask, because of the power of the subpoena, the power in lawsuits, when you get to a certain case, you can ask for data. They don't have to agree with me. They don't want me to have their data, but they have to give it to me, right? Because I've been hired by the lawyers to understand their business model. And that's kind of awesome, actually. That's my favorite kind. Because often in those situations, they're really bad actors. They're doing something pretty evil, and they don't want to tell me about it. They don't want to explain their work. They don't want to explain how their company works. But they don't have to, because they have to give me the data. And it's very satisfying as a data scientist to be able to say, listen, you don't have to explain this to me. I figured it out. I looked at your data. I know what you're doing to your customers. So that's adversarial. And then there's invitational audits where the companies ask me to come in and audit their algorithm. So do you remember Optum, the health insurance company? I actually talked to them 4 years before it became famous that they were doing something terrible. I told them to invite me to audit their algorithms. And they said, oh, we don't need you. And I was like, okay. They should have invited me. Now, by the way, the reason they didn't, and the reason a lot of companies don't, is because they don't want to know the answer, right? They don't want to know if they're failing to be fair, because it's more work for them to like make a harder. It's like I told you that they did what was easy instead of what was right. Well, that they wanted to do what was easy. It was cheaper. So a lot of the companies just don't want to hire me, even if they think they're at risk of doing something illegal, because they don't want to know the answer. They don't want to know how illegal their algorithm is. I think it's mostly that they think their competitors are also doing it, and why should they be the ones that do it right while the competitors are doing it wrong? So they have a kind of a point there. The invitational audits mostly happen when something is in the news and they're embarrassed and they want to be seen doing better. Or if they're afraid of regulation coming and forcing them to expose their methodology, then they're going to invite me. But usually they don't invite me. And by the way, when Trump was elected recently, all of the private companies stopped asking me. And that's because they don't think there's any regulations coming. And they're right, at least in the United States. Or it's possible that it could happen at a state level, like the state of Massachusetts, where I live, might start doing something like that, but not in the next year or two. So they feel pretty comfortable not asking for help. And then the final thing is, I also work for regulators. So regulators are in charge of asking all of the companies of a certain type, the type that they regulate. So I work for insurance regulators. So every car insurer in the state of Colorado had to give us all their data that we asked for, because we were in charge of figuring out what does it mean for car insurance to be racist. And there was no definition of fairness. There was no definition of racially fair in car insurance. So we were able to ask everyone in Colorado, all the car insurers, like many, many different companies, to give us their data. And that way we could compare them all of their policies. Okay, so I'm going to tell you a little bit about how I approach an audit. And this is for a very broad notion of an audit. This is usually what I do when I am invited into a company to audit their algorithm. And it does happen. And it's really stupid. It's like the stupidest possible way of doing anything. Because all I care, and I want it to be stupid. To be clear, I want it to be the most broad question possible. For whom does this fail? Who is this hurting? What does it mean to hurt? And who is it hurting? And what I love about this question is it is not technical, right? A lot of the stuff that's happening in the world of algorithms is that people are told, if you're not a data scientist, if you're not a computer scientist, if you're not a mathematician, you really don't have the right to ask questions. But this is the opposite. This is saying, who could be hurt and how? And so people can say, I'm not a math person, not people in this room, but people outside this room. They could say, I'm not a math person. Don't ask me to think about the algorithms. They're complicated. But nobody can say, I'm not a fairness person. Don't ask me whether something's fair. Everybody feels like they can at least defend themselves, right? They can say, I might be hurt by this. So that's the question we ask over and over again. And we build something called the ethical matrix, which is not a solution to anything, okay? It's just a set of conversations, like a round table. Imagine a round table where you ask everyone who could be hurt by an algorithm, what could go wrong for you? Every stakeholder, and that's what we call them. So we actually build a matrix, which is, you think of it as a spreadsheet, Excel spreadsheet, and the rows are the stakeholders, like people that care. That's one way of thinking about it. People who care about a system that is an algorithmic system. And by the way, I've fixed the context here. I should have said that, you're talking about the context matters. Fix the context and say, in this context, who cares about the outcome of whether this system works or not? And ask them, what could go wrong for people like you? Ask them. So this would be imagine like teachers, in that example I talked about with teachers, like, what could go wrong for you? Well, obviously, one of the things that could go wrong for a teacher is that they could get a terrible score, even though they're a good teacher, and they have no way to complain about it, right? So obviously, nobody did this process for that algorithm. And we do this. We have this basically roundtable discussion, although it's on Zoom now. And we ask people what could go wrong for you, and we collect all of the concerns. And then we rank them based on basically how likely are they, do we think they might be, and how bad would it be if they really are happening. Most of these are theoretical concerns, because just like I showed you in the examples, most of the time these kinds of harms are not measured by the people who build the algorithms. They're just not measured. People do not ask the question about the facial recognition. They don't ask, does this work as well for white faces as for non-white faces? Does this work as well for men versus women? Does this work as well for young people or old people? They don't ask that question, so they don't think about it. We don't know. But in a given context, it might really matter. So we're gonna start measuring, we're going to start ranking these concerns based on how likely is it and how bad would it be. And then we color code those cells. Basically red if we think this could be a real problem and it's probably happening. That's red, okay? And so I've given you an example of an ethical matrix for the teachers example I talked about. Now, these are the stakeholders. These are the people that you can think about as around the round table. But we're going to divide up the urban teachers from the suburban teachers, because the urban teachers are the ones that could get fired, and the suburban teachers didn't get fired. There was just no power in the scoring. They got scored, and they learned their score, but they didn't get fired if it was a low score. So obviously the concern is for the urban teachers, because they could get fired without understanding why. And that would be a false negative. Of course, the students care too, right? The students care whether their teachers are fired. But mostly the urban students care. And then you have the politicians who don't care about it at all. And the schools care about it vaguely. The data team, when I mean the data team, I mean the people who built the algorithm. I've talked to people who built that algorithm. And they told me that they knew it wasn't very good. They knew it was almost a random number generator for the teachers, individual teachers. They said it makes more sense if you look at the school level or the district level. Doesn't make very much sense for the individual teachers. And they said, we told the guys not to use it that way, but they did anyway. So these are the data people. This is a typical story for me because I end up talking to the people that built the algorithms almost all the time. The ones that were really harmful, the people who built the algorithms like, oh yeah, we knew that. We knew it didn't work. We told them not to use it. They didn't listen. And that goes back to what I was talking about at the very beginning about power. You know, it's not just about the theoretical design of an algorithm being accurate or something. It's really about who has power to change it and to decide how to use it. Does everybody understand this ethical matrix? Now notice it doesn't solve any problems, right? But it gives us an idea for what to be worried about, number one. And also, if we were in the pre-planning phase, if we hadn't deployed the algorithm, if it was just being built now, we could still build this, right? We could build it right now. We know the stakes are much higher for those teachers and those kids. And what we could do with that information is we could create what I'd like to think of it as a cockpit, like an airplane has a cockpit. Every single dial in the cockpit, you can think of it as like preventing an airplane crash, right? There's a reason that dial is there because you want to make sure the flight is safe. And each of these red boxes should be turned into a dial that we keep an eye on to make sure that the algorithm is safe, right? So what would that look like for a teacher's, what dial would this be, you know? And the answer is probably something like comparing the scores of teachers to another way of measuring whether a teacher is good that we believe in. Unfortunately, one of the problems with the conversation about education is that people don't agree with that. They don't agree about how to measure a teacher. They don't trust the principal. They don't trust this. They don't trust that. So there's a disagreement at a very fundamental level of what makes a teacher a good teacher. And instead of trying to work out some kind of agreement about that question and then compare it to this, which would have been hard, they decided to ignore that problem and just use this untested, unverified, secret algorithm to decide who to fire and who to keep. I'll just say one last thing, which is that many of the algorithms that I worry about the most are kind of like that. They're trying to avoid a difficult conversation. Like there's a conversation that really hurts, that's really, really fractious, and they're like, let's ignore it altogether and just replace everything with an algorithm. And that's always a mistake because algorithms don't actually like solve that problem, right? That's a human problem. And algorithms do not solve problems that we humans need to solve. Here's another couple of examples from the other examples I told you about the ethical matrix. And one of the points of the ethical matrix is that it dumbs it down. It's really easy to see the red boxes, right? It's also probably really easy to notice that the people that deploy the algorithm, the companies that deploy it, and the data team, they don't have red boxes, right? Why not? Why don't the red boxes show up on their rows? Well, because they're in charge. They want to make sure that the problems land on other people. They don't want to make sure, but they don't really check either. And then the facial recognition one is incomplete. We don't know the context of that, so we don't really know how big a deal it is that it works or is pretty bad. Are there any questions about this approach? Again, this is not a solution. this is a way of starting with a very big question, which is like, what could go wrong with this algorithm? Who could be harmed? And turning it into like really to-do list. And then the next step is to turn those red boxes into dials in a cockpit. So I want to talk a little bit more about those dials. And this is what I talk about in a paper I wrote with a law scholar. And it's a sort of a way of thinking about fairness. Often these questions come down to what is fair for women versus men, or people of color versus white people. Like, what does it mean to be unfair? So one of the things that I was really excited about when I wrote my book was that there was many, many anti-discrimination laws in the United States for housing, who gets to live in a house, right? Hiring, credit, and insurance. None of those fields had a way to deal with these laws in the context of algorithms. So that was what my goal has been, is to sort of figure out what does it mean to be racially fair, or fair gender-wise, or make sure that there's no ageism, or and I believe you guys have anti-discrimination laws here in Colombia as well. I'm looking at you. Yes, I'd love to hear a little bit more about them. So the question is, what does it mean if you're like hiring people, to make sure that the algorithm that you're using to hire people, which there's hiring laws that are anti-discrimination, how do you make sure that they are conforming to those laws? And as I said, I was hired to work this out in the case of car insurance. So yes, there's all sorts of laws on the books that aren't being actually implemented. And so the question is, how do you do that in a particular context? And so this is when I get down to very specific contextual details of a situation. And this is going to be the most technical part of it. You're going to first decide and I'm going to give you an example to think about, I think. Just think about hiring algorithms. You probably use hiring algorithms here. They're almost ubiquitous in the States. So when you apply for a job, your application goes through an algorithm to decide whether you even get to a person reads your application. Probably most of the time it's filtered out, and nobody ever reads your application at all. And part of that is because many, many more people apply for jobs now than they used to, because they do it on the computer. It's easier to apply. So there's hundreds of applications for 3 openings, so they filter out most of them. That's the very first step. But is it fair? That's the question. So the first thing you want to do is decide, what's the outcome you care about? And in this case, it's just be fairness, filtering. I want to know whether I get filtered out. We could be doing another example where it's like student lending, which I'm also going to talk about. So you borrow money to go to school, which I assume happens here too. And then the question is, the outcome could be like, do you get the loan, or do you get rejected for the loan? That could be the question you're asking. Or it could be like, well, what's my interest rate? Is it too high, or is it okay? So there's different outcomes that you could choose. And then you could ask, what are you worried about? You're worried about some kind of stakeholder group here. So we could ask, like, is this hiring algorithm fair to women? You could say, is this sexist? So should we be just trying to identify women versus men? How would you identify women versus men if you had a lot of data? I guess we could collect all the data that the hiring companies use. Well, what we do is we just look at the first name. And most of the time, first names will tell you pretty well whether it's a man or a woman. And of course, there's examples where the name could be a boy or a girl, and that doesn't help. But statistically speaking, it's very, very useful just to look at first name. Sometimes we're looking at race. That's a little bit harder, but it's not that much harder. We use something called the BISG methodology, which, by the way, is the Bayesian. Uses a Bayesian model. And there, what we're doing is we're trying to, for the race, that's for race inference. It's really race and ethnicity, and we typically use it to decide whether to guess that somebody's white, Hispanic, Black, or Asian, which is really very crude categories, but that's what we have. And what we're doing there is we have a census that happens every 10 years. And we're basically trying to guess what somebody filled out on their census. So we have their name, their first name, their last name, and their address. And that's enough to sort of have information about where they live, the census block. And if you look at the census data, you'll see that each census block, you can figure out the demographic mix. So if there's a particular census block that has 75% Black and 25% Hispanic, and you have a name, you're going to be like, is this Black or is this a Hispanic name? Does that make sense? Do you guys have census here with that kind of information in Colombia? Do people write down things like whether they're indigenous, for example? Yes? So you have information on your census that would allow you to do something like this. What's that? And gender? Well, gender is a little bit trickier though, because that's very mixed up, right? Whereas one of the reasons this works so well in the United States is because it's very segregated, actually. It's very segregated by race, not segregated by gender, almost at all, right? But the first name thing still works. So a lot of the last names, Hispanic last names, are very characteristic in the United States, usually. But there's a lot of Black Americans whose last name actually comes from a slave name. So the biggest mistake that this algorithm makes is that it identifies Black names as white because of that issue. We also use the first name, and that helps that problem because some of the first names of Black Americans are very characteristic Black American names, so that it helps to use the first name and the last name. So anyway, that's how you figure out the stakeholder groups. If you're looking at like whether a student lending company is giving worse loans to Black students than white students, you'd say, what is the interest rate, and who's Black and who's white and who's Hispanic and who's Asian? Does that make sense so far? And then what do you do? And this is the nuance. This is the context here. And before you look at that loop, it is a loop. It's a loop until you're done. And by the way, this is what I like to say is like, I do the easy part, but the lawyers do the hard part. Because this is really a conversation between lawyers that I'm just sort of overseeing. So I was actually hired to do that example. So I'm going to talk about that example. I was hired by an attorney general, which is like an enforcement agency. And they asked me to look into whether a student lending company was being racist. And we decided to look at the interest rate for different loans. And what we did first was we just measured, we inferred the race of these students based on their first name, last name, and address, like I just mentioned. And then we just looked at the difference. On average, Black and Hispanic students are paying this interest rate, and white and Asian students are paying that. And that's typically what we do is we combine white and Asian with Black and Hispanic, because usually these two are worse off and these two are better off. And we found a big difference on average. And so we reported it. We reported it to our boss, the attorney general, and they said, okay. And they went to the company that we were investigating, and they said, there's a big difference. So there's a big difference, yes. And the company said, oh, there's a valid reason for that. We can explain that. We can explain that for a legitimate reason. Okay, what's the answer? What's the legitimate reason? Well, we use FICO scores. We use credit scores, and we give better interest rates to people with higher credit scores. Do you guys have credit scores in Colombia? So if you have a higher credit score, you get a better deal. Well, is that legitimate? It's a really good question. Part of the reason it's a good question is because these are kids. You know, these are 17, 18-year-old kids. How did they even have credit scores? Probably they inherited them from their parents, basically, which is already a question. Like, why are you punishing these kids for their parents or whatever? Or basically it's their class, right? Like where did they grow up? You don't have a lot of data. You don't have a lot of behavior of a kid going to college. All you have is kind of like context of their childhood. That's the first thing. Also, it's well known that FICO scores, credit scores in the United States are racist. Let's say it this way, they're correlated with race. They're correlated. So is this legitimate? Well, the thing is that there's been a lot of use of the credit score to decide how to lend people. And it's been over and over again, it's been considered okay by the courts, the court system. So we had to say, okay, fine, it is legitimate. That's what our boss told us. And this is where we did the math. We said, okay, we're going to account for it. We're going to account for that. And we're going to remeasure this gap. So we started with the big gap. And we said, this is a huge gap between the interest rates. And they're like, oh, there's a legitimate reason. And it's the credit score. And like, okay, we're going to account for that. And we can remeasure it. So we accounted for it, which is, I know some of you are students of Edamon's taking his linear algebra class. Are you doing any linear regression? So we just used a linear regression to account for the credit score. And what happens is the gap got smaller, right? And nobody should be surprised, because if you're allowed to use a racist proxy, FICO score, a credit score, if you're allowed to use a proxy for riskiness, like that is correlated to race, then the gap that's measured along the race goes down. But it was still big. It was still a big gap. And so we went back to, so we got back here. Are there big differences? Yes. We went back to our boss and said there's still a big gap after accounting for credit scores. And of course, our boss went to the company and the company said, oh, we can explain that. They always can. They always have an explanation that they think is legitimate. And then the question really is the legal question, and this is the hard part, okay? Is it legitimate? That's not a math question. That's not a math question. That's a legal question. And the next thing that they thought was legitimate was, they said, we charge more, we charge less for people who go to colleges that are highly ranked in the ranking system of colleges. Do you guys have ranking systems for colleges? We have something called the U.S. News and World Report ranking systems. So you have a very elite colleges, usually very expensive, are highly ranked, et cetera. And as I just mentioned, there is a correlation with money, right? The highly ranked schools are usually for richer kids, standardly. And so that's like already a problem. Like, wait, why is that legitimate? That you charge, basically you charge people more if they're going to a school that has poorer kids. And so luckily, again, not my job to answer that question, whether that's legitimate. But that's the idea of explainable fairness, is that it's a kind of a negotiation between lawyers. One of them is always just interested in money. They're just interested in profit. They're like, listen, we're gonna build our model to maximize profit. And we don't care about anything else. We don't care about fairness. And then there's the other side are supposed to represent public interest, essentially. And they're supposed to decide whether things are legitimate or not. And the idea is you just keep going and you try to get the gap smaller and smaller. If the gap gets small after accounting for legitimate factors, if it gets really small, and by the way, small is the threshold I talked about earlier. I don't know what small means, but luckily that's also not my job. If it's small enough, then you're like, okay, good, this is fair. But if it doesn't get that small and they can't come up with any more legitimate factors, then you have a big gap and you're like, that's too big. Does that make sense? So that's my job. I do that. BIFSG, and I'm going to share this with Edamon if you guys want to look at this stuff up. That's the Bayesian inference methodology I mentioned, is well documented. It's really interesting, and it could be changed easily to a different kind of census with different kinds of categories. Edmond was telling me that there's something called estratos here. I feel like that's probably, is it illegal to discriminate against people in estrato 1? Yeah, so that's what I would be doing if I were working in Colombia. I would be like changing this to try to understand estratos discrimination. And this is the paper I wrote with my colleague Jake and a really nice woman who's a legal scholar, Holly Sargent. And here's the example I just mentioned, the student lending. The outcome of interest is the APR, or it could be whether you get rejected outright, but nobody does. Actually, in cases of loans, most of the time, there's nobody who gets rejected. They just get a ridiculous high interest rate, right? So that's really the question that you're asking, is the interest rate unfairly high? And then you have to infer the protected class status somehow, which I just mentioned with race, but you could do it with gender, you could do it with age. There's other kinds of protected classes. What are the protected classes in Colombia? Children. Yeah, children do have some extra rights in the States, but they aren't protected at all, actually. And then you measure the outcome, and then you say, what's legitimate? The FICO score tends to be a legitimate. The other thing that they mentioned that the company wanted to consider legitimate is the major. Like, are you becoming an engineer, or are you becoming somebody who does marketing? And they want to give better APRs to people that are going to be in STEM, basically. What bothers me about this type of major is that I also, because I do a lot of different algorithmic auditing, lots of different fields. At some point, I was doing auditing in education. And I was going to colleges, and the people in colleges were very excited because they had a new algorithm that was going to funnel kids into different majors. So they were going to get to college and be told, you should major in this, you should major in that. And it was basically like, people like you major in engineering, and people like you major in communication. And it was just a way of funneling them into things that guaranteed that they would graduate. It didn't mean it would be good for those kids. It didn't mean that that's what they wanted to be, right? It was just pushing them into a field. So the idea that they would be pushed into a field that was not very well paid and then charge more for it because they were in that field, that's pretty obnoxious. So that's not surprising either, right? One of the things that we have to understand about algorithms in like our modern world is that they're all working at the same time on us. Like, they're profiling us and pushing us in a trajectory that they think we should go on. And there are multiple ones happening at the same time. So it shouldn't be surprising that you're being pushed into a particular college and then into a particular major, and then you're being given a worse deal for your student loans. And it's all the same, really the same profile. I want to show you one other example just to show you how different it is. I audited disability insurance. I don't know if you have this in Colombia, but you can buy disability insurance in the States. So if you get injured while you're working, then you get paid for a few weeks to recover. And we wanted to know whether that was fair. And that's because the insurance has anti-discrimination laws too. Was it racially fair? Was it gender fair? And one of the things that you could ask is, did your claim get denied at all? It just rejected. Well, that's one way to measure unfairness. But what we were interested in was the length. How many weeks of pay did you get? And was that fair? And what's interesting is it's same idea, right? Same idea. Let's say we're doing it by gender this time. Are women being given enough time to recover versus men? Well, what if we see that women are being paid, they're being given much less time? So it looks like a huge gap between men and women. Why are women getting so much less time? And the kind of legitimate factors are very different in disability insurance. So one thing that is legitimate is age. It is legitimate to consider age in deciding how many weeks of disability insurance somebody gets. Why do you think that? Why do you think it is considered legitimate? Anybody? Younger people recover faster. Here's another thing that's legitimate: the type of work you do. Because if you have to get back to like a job where you're using your body to move things, like a manual labor job, you have to be really better versus if you've got a desk job. Right, and think about that last one, the desk job thing. More women have desk jobs. More men have manual labor jobs. So when you first measure the gap, it looks like men are getting way more time, but when you account for the type of job, that gap gets really small, much smaller. Does that make sense? And so you just keep adding legitimate factors until you're looking at the gap and you're like, oh, actually, that gap doesn't seem as big as it started out seeming because we accounted for legitimate factors. Comorbidity is another one. Comorbidity means like, do you have diabetes? Diabetics take a lot longer to get better if they break their leg or something. What is not legitimate here, though, is FICO score. Credit score does not count as legitimate in this context. It should not mean that you take longer or shorter to recover from a broken leg because you have a FICO score that's higher or smaller. So that would not be considered legitimate. So I'm just going to go one more time, go back to that point I made at the beginning, which is that context matters so much. The details matter so much of exactly what you're talking about. I'm talking about gender fairness, and I'm like, FICO score shouldn't matter, but it does matter for racial fairness in student loans. Okay, so that's how I think about fairness. And one last way of saying it is really just thinking about measuring this gap appropriately, and then letting lawyers argue, lawyers and regulators and people that are supposed to be protecting the public, what is a legitimate way of discriminating. To be clear, all of this is discrimination, right? These are all scoring systems, and they're all going to discriminate based on who you are and what you do. So the question isn't, is it discriminating? It's just definitely discriminating. The question is it legally discriminating? Is it legitimate to discriminate in particular ways? It's definitely not legal to discriminate by race specifically, but what you'll see is that a lot of these legitimate factors are in fact correlated to race. So you have to really be very careful in that conversation. My last thing I want to mention is I started a new company called Ocean, which is like a nonprofit company. I think I told you guys that when Trump was elected, all the private clients were sort of disappeared. And in fact, there's a lot of lawsuits now, and that's because there's no regulation at all at the federal level or even in Europe at this point. There's no regulation. There might be some regulation coming at the state level, but it's going to take a couple of years. So the leverage I have, what I care about is algorithmic harm and protecting people that are being harmed by algorithms, right? The leverage I have is lawsuits. And the lawsuits that are happening are typically things like, you guys know about chatbots, AI chatbots, like the kids getting on chatbots and then like killing themselves, or kids getting obsessed with social media and getting very, very sick, like either mental health problems or like they're getting anorexic, having eating disorders. And so that's the kind of lawsuit that I want to be helping with. But the law firms that are doing this work don't have any money. And they're going up against these enormous companies, right? Like they're going up against OpenAI and Google. And so my idea was, I'm going to just start working for the good guys. I'm just going to work for them, and then I'm going to hopefully raise money to pay for my time. And the way I got the idea of doing this is that I got an email asking whether I do expert witnessing work for lawsuits about algorithmic discrimination. And I was like, oh yeah, I do that. That's great. I'd love to do that. And they said, oh great, we'd like you to work for TikTok because they were accused of harming young people's mental health. And I was like, fuck no, I'm not going to work for TikTok. Please come back when you have a job that I could live with. And they're like, sure, I understand. I wouldn't want to work for them either. That's what they actually said. And they're like, we'll keep you in mind. And I was like, great, but like, you're never going to have a job for me. You're an expensive company headhunting for an expert witness. I want to go find the people that I want to work for. Go find those lawsuits and just go volunteer to work for them. So that's what I'm really excited about doing nowadays. And I think that's, oh yeah. So what we do is we help the lawyers request the data. We basically say, what is the sentence you want to say to the judge in English? And then we'll back out, what's the evidence you need, statistical evidence you need to convince the judge that this is happening to kids at a very serious level. And then we back out, what's the data we need to build that evidence so that you can say those things to the judge. And then we will explain our reasoning as expert witnesses. And we'll also educate the lawyers and the judges who don't understand algorithms at all. How does algorithmic auditing work? And you guys already know how, I mean, this is you already know way more than judges and lawyers. So that's what we're doing now. It's really exciting. Thank you very much for your attention. I'll take questions. Yeah. Yeah.
Hola.
Vamos a tomar algunas preguntas para Cathy y también aprovechar el bloque también para Gustavo, así que en principio aprovechamos que Cathy está ahora y luego también si hay alguna pregunta para Gustavo, adelante.
Hola. ¿Quién es?
Hi, my name is Alejandro. I have a question for you because this is the first time that I hear something about like an algorithm to audit algorithms. And at the end, you also say that when Trump was elected, some of your private clients just disappear like that. So I was wondering, in our field, where or how where or how can we find space if we want to go with this like idea, an ethical idea to audit our algorithms or the type of job we're gonna do, because I think the word, as far as I know, and of course the state and the private companies are looking just like profit, and they are ignoring a lot of these ideas that you're talking about today. So I'm just in first semester, and as far as I know, it looks like, I mean, this is the first time that I hear something about this, so this is actually very good. So I was wondering if it's that hard to find a space, or how can we try to work in this, because it looks like the words it goes in a different way.
Right. Yeah, that's a really important point. Like, I have been very lucky since I've wrote my book to not have to work as a data scientist in a company that is only for profit and doesn't care about this stuff. It's way easier to get a job as a data scientist in one of those companies where you're going to tell the company, hey, don't use this for individual teachers, and they're going to ignore you, right? Because you don't have any power. You're just working at the company. So I've been thinking about this for years. And part of the reasons I started this ocean is because I really feel like the future of data science isn't just to work for for-profit companies. The future for data science is also to work with lawyers on behalf of people who are being harmed. So it's actually a whole new field. Like it's a whole new approach, but it requires enough education by the judges and the lawyers to say, what we need here is a data scientist, right? Because think about it this way, every bureaucratic decision is being used, computers are being used, algorithms are being used for every bureaucracy. Who gets hired, who gets fired, all of this stuff. It's because there's a lot of harm, but there's some sense it's good news because there's a lot of data. So unfair practices are being documented, which means that if you want to sue, the documentation exists, the data exists to make your case. And it's not just your case. That's what's exciting about this as well, is that it's not just your case, it's a systematic case. People like you are being harmed. Like you have to change the whole bureaucracy. So I'm not saying it's an easy job to get. I'm saying it's a job of the future, because in the future, there's no doubt in my mind that lawyers will be working with data scientists, because everything that they're suing on is an algorithm, right? Algorithms are everywhere. So they have to get to that point. And so there will be jobs like that.
Yeah, hi. So you mentioned about the manual and the desk example for women and versus men labors. So this is kind of related with Simpson's paradox. It's like a group data shows a relation, and okay, so that makes even more subjective the fairness concept when you study the data. So how do you like discern with something it's like that?
Great. Thank you for asking that question. It's a great question. And it's a nerdy question, which is appropriate for today. It's a bunch of nerds here. I see that. And I love that. I'm a mathematician. Simpson's paradox is when you have one effect, if you look at it as a full group, and you see the opposite effect if you look at it in a segregated fashion. So the famous example is it's like more difficult to become a graduate student at UC Berkeley if you're a woman than if you're a man. But if you look at what department you're looking at, you see that it's actually easier or the same for each department for women versus men. So it's like overall looks bad for women, but if you look at it per department, it looks fine. And what's really happening is that more women are trying to get into more difficult departments, right? And that's a choice they're making. So it's not actually a problem. But I will just say it this way. What's actually happened there in the language that I just described is that looking at accounting for department is legitimate, right? So in other words, you have to have an explicit conversation about what is legitimate. And if you did that, you would say departments are like accounting for the department, because that's a choice that the woman or man is making, is legitimate, and you would be looking at that second graph, not the first one. So it's not a paradox. No paradox is a paradox, by the way. It's just a way of thinking about it more carefully. So here you have to ask what is legitimate when you're asking about this question, and then it's not a paradox. Does that help?
We're going to give space on 2 more questions, and then maybe 1 extra for Gustavo.
Okay. Hey, hi, Katie. So I have 2 questions, so let's be brief. One is the technical, and the other one is structural. The technical question is, so your work handles the outcomes, and the algorithms, how do they handle it? Like just as an explanation to the lawyers, to the people, but never to, or do you try to interpret, like I was thinking like with these big AI models, so then you cannot even get the data, replicate. So the other one, the structural, is like, I kind of tend to think that justice is for the rich. So, and you talk about lawyers and you have to work intimately with them, and I don't see why a lawsuit will happen. Like it's, I mean, I live in the States, so I see the amount of resources. Like, do you see any way of going like changing that?
Okay, so the first question is, I only look at outcome. I don't look at code. I don't care about how algorithms work. I don't care how the builders of algorithms thought about it. I just don't. I only say, give me the data of who entered the system and how they were treated by the time they left. Because it doesn't matter how the code was written. It doesn't matter what the algorithm maker thinks is happening. They're often wrong. I've built code. I know that I don't understand my code 15 minutes after I make it, right? So it's just a question of how are people actually treated. It's a black box audit, okay? And I will defend that. But the second question is really important to me. Justice is for the rich, and that's true right now. And that's because fancy lawyers are much better at making the case for their rich clients. That's one of the most exciting things about working as a data scientist alongside lawyers. Because as I said, I'm not just saying that one kid got hurt by a social media algorithm. I'm showing you, I will be displaying with this the data that this is happening to a class of kids. Many of them do not have lawyers.
How do you even get to that point?
How do you get those lawsuits? It requires intrepid activist lawyers. But the point is that I'm giving them a superpower, which is the data analysis. And that it really is a superpower. Because as I said, these things, everything is documented, including the harm. Those social media companies document the harm that they're endowing on kids. They document it. They have all the data. They don't want to look at it. But a judge who's thoughtful will say, you need to show them the data so that they can look. So that's the idea.
Okay, have you ever encountered, you talked about OpenAI and...
Can you be closer to the mic?
Sure. So have you ever encountered, you talked about OpenAI, ChatGPT, all those models that with AI, they become black box models. Have you ever encountered a situation where they said like a legitimate reason is like, we don't know the weights, all that's happening, the neural networks, we're not sure what happens. That discrimination is beyond what we could do or think because it's like the type of data that it's being fed or some kind of stuff. Like the company doesn't have to answer to those things. Have you encountered that situation?
Okay, to be clear, like I'm just going to repeat what I said. I don't care how the underlying algorithm works. I do have to, at some point, we have to focus on binary outcomes. Like, are you a child or not? Right? And did you talk about suicide or not with the bot? And that might be hard to measure. It's not going to be a perfect measurement. But at the end of the day, we're going to say, are you, chatbot company, leading children into conversations about suicide? And so it's going to be a binary outcome, but I don't care which AI model it is. I don't care what the underlying neural network looks like. I'm just going to be measuring the outcomes for this. Does that make sense?
So I'm really sorry that there are a couple of questions extra, but in honor to the time, anyway, I invite you to stay a little bit maybe longer and then to chat with the people that are interested. Maybe here, there, we have an extra question. Entonces, en honor al tiempo, thank you, Cathy, once again. Maybe a clap for her once again. Thank you. No quiero dejar pasar la oportunidad para nuestro primer speaker, así que si alguien tiene alguna pregunta para Gustavo, podemos estar tomando ahí unas 2 preguntas. De todas maneras, Gustavo también va a estar quedándose durante toda esta semana, así que también aprovechen cualquier otras instancias para poder acercarnos. ¿Tenés una pregunta ahí? ¿Podrías decirlo como lo más fuerte que puedas hasta que llegue el micrófono? Les pido por favor un segundito más si se pueden permanecer en el salón, 2 minutos más y ahí ya nos retiramos todos, o si no, si lo hacen, que sea con extremado silencio. Muchas gracias.
Bueno, en mi caso la pregunta es, ok, pasamos de tener este modelo donde cada uno apostaba por su cuenta y al, digamos, reunir todo el dinero y apostar de nuevo en un fondo, pues empezamos a ver cómo las ganancias se acercaban al esperado. ¿esto en la realidad llega a tener algún grado de fallo? Porque eventualmente, si no, sería como la fórmula del dinero y pues definitivamente no se hace por algo, pues estos casinos siguen existiendo y nadie se hace millonario de esa manera, con lo cual, ¿dónde entra a estar el fallo de por qué esta estrategia no termina de funcionar?
Hola, bueno, ¿se escucha?
Sí.
Esta estrategia es la que se usa para apostar. El Kelly Criterion es el que es óptimo para apostar. Si quieres apostar, busca Kelly Criterion y vas a... No hay nada mejor que se pueda hacer, en principio. Hay incertidumbre. Kelly lo que tiene es, lo que vimos hasta ahora fue apostar todos los recursos. Kelly lo que te va a decir además es, no apostes todos los recursos, cooperá con vos mismo, guardate un poco de la plata y solamente apostá a una de las opciones, porque de alguna forma si perdiste, entonces tenés tu ahorro, y es como que reducís fluctuaciones con eso. Y hay una forma óptima de apostar.
Mira, qué interesante.
Después, claramente, depende cuánto crezca, cuál es la tasa de crecimiento, sí depende de los pagos que haya. ¿Sí? No la comparación, sino la tasa de crecimiento sí depende de los pagos. Entonces, un casino, por ejemplo, va a ofrecer pagos que no te van a permitir ganar, aunque cooperes. De hecho, el pago que es inverso a la probabilidad real impide ganar aunque cooperemos. Así que bueno, tienes.
¿Tenemos espacio para alguna otra pregunta? ¿Alguien más va a preguntar? Listo, chicos, les recuerdo que a la 1 tenemos el